Hello and welcome. I am Ebormeki Lyngshing, and this video will be a review of the basic matrix operations. We are going to cover 4 different operations here, and on top of that, I just want to have a small note on how we define these. So for matrix definition, let's say we have some matrix. This matrix has a number of rows and number of columns. And with these two pieces of information, we define the shape of the matrix. This is a 2 by 3 matrix because it has 2 rows and 3 columns. If we have a matrix that is 3 rows and 1 column, it will look like this, which is a 3 by 1 matrix. Now, the first operation we are going to talk about is called the transpose of a matrix. And all the matrix transpose does is change the shape of the original matrix by flipping it. So, if we have our same matrix as before, 1, 3, 2, this one, the transpose of this matrix will be 1, 2, 3, 4, 2, 7. So the way this works is the first element stays the same, but for the second element in the row, we actually look to the second element in the column, and so on. So next, let's look at addition and subtraction of a matrix. The basic idea is that for addition and subtraction, we just look element by element. So we have to add and subtract. So if we have to add and subtract matrices that have the exact, the matrices should have the exact same shape. It means that if this matrix here is a 2 by 3 matrix, the matrix that we are adding to it also has to be a 2 by 3 matrix, and we are going to end up with a 2 by 3 matrix only. This element we get by adding this first element here, and this 1 plus 0. 1 plus 0 will be 1, and 3 plus 1 will be 4. 2 plus 5 will be 7. 2 plus 3 will be 5. 4 minus 2 will be 2, and 7 plus 8 will be 15. So now we'll talk about multiplication. Let's take the same matrix as before, and we are going to multiply it. And we are going to multiply it with a 3 by 2 matrix, because this one is a 2 by 3 matrix. And we have to match, and for multiplication we have to match this column of the first matrix with the row of the second matrix. So the column of the first matrix and the row of the second matrix should be the same if you want to multiply these two matrices. So this element here we get by multiplying 1 and 0, 1 into 0, plus 2 or plus 3 into 1, 3 into 1, plus 2 into 5, plus 2 into 5. So basically we are just multiplying this row with this column to get this element here, which is 13. And for this second element, we have to multiply the same first row with the second column, because it is in the first row and it is in the second column. So we are multiplying 1 and 3, 1 into 3 plus 3 into minus 2, 3 into minus 2 plus 2 into 8, 2 into 8. And for this third element here, we are going, because it is in the second row but first column, we are going to multiply this first or this second row with this first column. 2 into 0 plus 4 into 1 plus 7 to 5, which is equal to 39. And for this last element here, we are going to multiply, because it is in the second row and second column, we are going to take this second row here and multiply it with this second column here, which is 2 into 3 2 into 3 plus 4 into minus 2, 4 into minus 2 plus 7 into n, 7 into n, which is equal to 54. And now last we'll talk about the inverse of a matrix. So let's take any square matrix, let's say A, and if we multiply this square matrix with the inverse of n, which is inverse, we will get an identity matrix. And identity matrix is of the form, let's say this is a 4 by 4 matrix. 1, 2, 3, 4. And this identity matrix should look like this, which has one in a diagonal plane, diagonal line like this or like this, and the other should be 0. Thank you.